Working with JavaScript, one of the things that we need to do with it is we need to put it into a document. So I have a HTML5 document, so I just have doc type HTML. HTML5 is awesome. And with that, I put my script information inside script tags. Now, it's not a bad practice. Sometimes you can actually add in script type equals text / JavaScript, because that will tell your code reader that, oh, this is JavaScript and this is how you should interpret the programming instructions it sees in that script block. But it's not mandatory. The code will still validate without that little element. So we can, if we're so inclined, I can go, oh, hang on, try again. Type equals text JavaScript. So I can do that, but it's not necessary. One of the beauties of HTML5 is we got rid of so much stuff that the web page became something you could actually have memorized instead of having to use a template for fitting in your doc type information and all that other garbage. Anytime I'm doing a script and I want to put JavaScript into it, I either need to have a script tag and put the script directly in it, or I need to use the script tag to link to an external JavaScript file, and it would be a .js file that we would be creating. And we'll be moving that way shortly, but not today. Today we're just going to be putting our scripts directly inside our main document for ease of purpose. Now, where that script goes inside the document, so currently I have the script here and it's in the body. Sometimes you will see where the script occurs up in the head. And if it is in the body, is it occurring before or after content within the body? So do I have a paragraph here? So do I have a paragraph and then I have my script, or do I have my script and then my paragraph? All of these things actually are going to have consequences, and where we put the script will matter. Sometimes it's a performance issue. Sometimes it's actually a requirement issue of our script needs to, if it's trying to access my document, the contents that it's trying to access need to be loaded into memory before my script attempts to access them. Otherwise, I will get a nasty error message if I know where to look. If I don't know where to look, I get a nasty error message, but what it appears to be in the web browser is it appears that nothing happened and it failed silently. So this is a very common thing with JavaScript, is it appears to fail silently until you actually go to where we're going to go next, to the console, and you go see, hey, look it, and there's an error message occurring there, and then you get to see. But first, it's nice to have a script work before we make it actual fail, because we don't want to fail right away. That's just a bad habit to get into. So if I type this, I can now hit Command B, and we can say, hey, look, see, it says hello there. That's the paragraph that was as part of my document. And I had a script that says console.log, which means it's logging a message to my console. Well, the console isn't readily visible. I need to make my console visible, and I'm able to do that by going under my View pull-down menu. As you can see, I've got to remember which menu it's under because it varies between web browsers. And what you're looking for is your developer information, and then what we're able to choose is JavaScript Console. And it's Command Option J if you're on a Mac, and I'm assuming then Control Option J or Control Alt J if you're on a Windows machine. That pulls up my JavaScript console, and I will see inside that console, which down at the bottom in my developer tab here, it's showing the console, and it shows me, hey, look, there's that message where it says hello world. If I go back into my document, I see it says console, log out, or tell me a message, and it says hello world. And of course, we're using the ubiquitous very first programming technique of sending ourselves a message by saying hello world. Now, the console is the same place that error messages will show up. So if you visit a page and if there's any error messages or a page you create and there's problems occurring, all of that information will be in the console. So you'll look at your page and it's looking okay, but if you pull up the console, that's where you will see where if there's an error message or not. So I'm just trying to I'm just trying to think how to break it here. Okay, so I generated an error message. So it's possible to generate, if I have an error message, they always show up bright red like this and very unhappy looking, and then makes you cry. Now it's really normal when you're working, you'll keep doing things. It's not working right, it's not displaying right, it's not acting right, it's not animating right, and you're like, argh! And you get really frustrated, and then you realize after about a half an hour that if you just checked your console, you'd realize the very first error message that came up told you exactly which line was wrong, and you could have fixed it right then, and instead you just wasted all that time because you didn't have this up. So having the console up. So in Chrome, we're able to choose this, as Heather found it, it's under if you choose Inspect, that pulls up the elements for your page. But all of this is under View, Developer, and then we can just choose. And I like with the now it goes away. But with the JavaScript console, it comes up. Now I can see the elements that are being used on my page, where it shows me my code. I can see everything that's there. It shows any resources that are being used and network, and it gives me console. Console is probably the most important place you're going to be, because in the console, that's where we can find those messages, troubleshoot them. So it tells me that there's a problem on line number 9 in my document. I go to line number 9 and it says if Fred, and it's like, well, it can't really do anything else after that. I'm asking, hey, is Fred true, by saying if Fred, but Fred was never defined, therefore my error message says reference error, Fred is not defined. Well, of course Fred's not defined because I never defined Fred, and we will talk about variables and refresh on variables a little bit later today, because variables are where that's where things get interesting. Once we can store data so then we can remember it to do something with it later, that's where the whole world gets a whole lot more interesting. So we'll be moving to variables soon. But the console is where these beginning documents right now, I'm not writing to the HTML, but I'm just sending messages into the console. So if you looked ahead and looked at some of the other documents, you will see that all any of these documents do is output information to the console. They're not doing anything to the HTML. Because in the beginning, we just want to understand some of the foundational principles of the scripting, and then we're going to start using the JavaScript to control the DOM, or the document object model elements. So we will now control the DOM. We will change contents of it. We'll move things around, change their styles, and just do all kinds of cool stuff. But that's what we have to move to. But right now, we just want to send ourselves a whole bunch of messages. So those who have done some work in Flash, this is console.log is the same as using a trace statement, which is something we use incessantly when we're doing Flash development work. And in processing, we used print line to send messages to ourselves. Here we're now using console.log. So we're sending ourselves a message. That's all console.log does. And anytime the web browser needs to send us a message because we screwed up, in its opinion. In the opinion of the web browser, our code screwed up. Our code could be just fine, but in its opinion, it's not. Because each browser, some browsers will go, oh yeah, your code's great, and the next browser will be like, So it's in the opinion of the web browser that you screwed up. It will send you a message, and it does that message through the console. But because the console is not regularly visible, we don't get to see that message. Therefore, we will look and go, well, what happened? We don't know. So that's really what's at play there. Moving into the next document, dealing with numbers, what we will see here is we're able to now create a variable. And we're going to use variable numbers first, or variables as numbers first. In many languages, we're required to specify what kind of object that variable is. Is it a number? Is it a string? Is it an image? Is it an array? Is it something? We have to tell our compiler, oh, this is what that is, so you need to deal with it in this certain manner. JavaScript, all we do is say var. We just type in var, V-A-R, and then whatever name we want our variable to be, and then an equal sign and whatever value we want to assign to that variable. Single equal sign is used for assigning a value. So with this, in many ways, it makes it a whole lot easier, but in some ways it makes it harder because by not having to specify in the beginning what kind of data type a variable is, down the road, we can get into trouble if we put in something that is a string and we needed it to be a number and vice versa and didn't pay attention to that subtle nuance, because a string is letters like a word, it's characters, and a number is a numerical value, and they may not be the same. Because if I type in 12 but want it to be just representing the word 12, so I use a 1 and I use a 2, but it's 12, versus the number 12, they're not quite the same, and we will be comparing them and talking about that in an upcoming document. But right now we can see that we can set up a value and call it 12. Now, it seems silly to say my number is 6 plus 4. Well, wouldn't that just be 10? And I could have typed 10. But the point that we're trying to do here, and I'm going to just put a 2 on that, is that when you construct a variable, you can use multiple items and combine them together to turn it into the object you want it to be. So number 2, as I've now changed its name, is 6 plus 4. So that would be 10. But I could just as easily say it is number. So number 2 is equal to number plus 4. So when we construct a variable, we don't always assign a specific concrete finite value to it. We may assign it a value based on a relationship to some other value. Now if I run this document, console.log is going to log out my number. So when I pull my page up, of course I see a blank screen until I then pull up the JavaScript console. The reason that this creates our cryptic 1216 instead of showing 28 is we started our log statement with actually a string. I put quotation marks, which means I am putting a string or characters in, such as my number is. So it's a string, it's letters, it's characters. When it's a string, and then I put a plus, it goes, oh, well, you just want to add more things to that string. It doesn't realize it was, kind of theoretically could have added those numbers together. So now when we look at it, we can see my number is 1226. So we can see how it puts that in the document. We'll pull this up higher. Oh, look, I can go bigger. There we go. Now we can actually read what it's putting in my console, so you know I'm not just lying to you about it. So by preferencing our log statement with a string, it assumes that we want to treat our numbers that we have as a string. And this is where we move into kind of equivalency of data type. Letter, number, are they the same? Are they different? As we can see here, now it goes, oh, well, we just wanted to see them side by side. There's no space between the two numbers because I just say number and then show me the next number. If I wanted to see a space, I could put in a space. Number 2 is, and then add another plus sign there. So the plus says keep making this string longer. I'm going to look at it, and my number is 12 and number 2 is 16. So it's a string that we're adding in. The next document, as we look here, we'll see that I have two numbers, and then I created a third variable which is composed of adding those two numbers together, which is kind of like what I cheated and worked ahead with in the previous example. And then we log that out to our console. So if we look at this, we'll see that those two numbers come out, and then we get 7. And looking, we can see 4 plus 3, and it will just add them together because it assumes that they need to be added. So it's creating that total. So adding is one of the more common things we'll do. Different mathematical operations on the computer have different performance implications. Addition is generally considered a low cost. Subtraction can be a higher cost operation. Multiplication is low cost. Division is a high cost. So anytime you're calculating, trying to work out with values, if you can always phrase your math as in addition or multiplication, you're generally going to see the greatest performance benefit of it. Now, I can't think of anything we do this semester where we would probably see any real performance degradation by using other, different math operations, but addition and multiplication are generally considered far better performing, and division is to be avoided as much as possible. So you want to avoid dividing numbers if you have any way of doing so, because it just eats up power. Okay, so moving into a little bit more math. So if we have our first and second number, we can add them, multiply them, divide them, and subtract them. Notice for division we are using the slash. We do not have a division key with a little dot, horizontal line, and a dot below it sort of math symbol. We just have the slash. That's going to be the accepted symbol for dividing two items. So we can create a sum and a product and a quotient and a difference, our respective math operations. And then if you think about it, you could think about what you think the answers are going to be to all of these, and then you could actually go and check if your thought lines up with what the console spits out to see if you're on track for what numbers are being generated, to make sure you're correct with that. You can see the numbers that it spits out. Now, when sending messages to the console, it's not a bad idea to put a little more information in that so that it can make sense out of it. So total is first number plus the second number. So it's done the calculation ahead of time. But if I wanted to then add an information such as the sum is like that. So it's going to put out the string, the sum is, and then after that, and after is, I did put a space so that the number won't be touching it, just so it looks a little bit better. And then it will display total. Now it's showing total after this text, but because the math has already taken place, it's not going to be like our previous example when we looked at where it showed 1216, but instead we will actually get to see what is the total number. So the sum is 7. So now we know that it works. Now if I wanted to be really complete on it, then I would even add in one more element, and I would put a period at the end so that it reads as a complete sentence, just so it shows up the sum is 7. I probably should capitalize the T in the, just as long as I'm trying to be better with my grammar there. So out of completeness, I feel obligated to now do that. So the sum is the total and then a period. If I'm sending messages to the console, I highly recommend I don't just send a number, because sometimes I will send like an X value or a Y value or a score or a position information or a file information, a path. And if sending this information, I like to always put some extra text in that message I'm sending to myself, just so that I know exactly what it says. But I also will know that if it spits out this message in its entirety, I know exactly what line in my program that came from. So that's really important. So I find that to be helpful. All right. All right, so I've already thrown some strings in. We've seen that. Not going to continue with that. We've already added strings together. We can see where we're even combining things and then using a third variable to combine them and then put that in of hungry and hippo, and it goes all together. A nice little space between the two. And get hungry hippo. So when we're combining strings, combining numbers, if you combine a string and a number, it assumes that number is just like more letters. But if you combine two numbers and there's no strings involved, it assumes they're actual numbers. They're mathematical values instead of letter and character values. So you may feel that I'm harping on this a little bit, but it really is kind of a big deal as you start building more complex programs and keeping track of your pieces of data. So it is something that really needs to be taken to heart. So moving forward, we need to understand a concept of true and false. And this really boils down to, at its essence, what the computer is doing. It understands true and false, 1 and 0, on, off. And once you come to grips with the fact that that's all your computer actually understands is true and false, and everything is building up from that, sometimes it can get a lot easier to solve your problem. So the computer doesn't look at things with a multitude. That's just, is this thing true or false that you're asking me? That it's just plain and simple, true or false. That's what it knows. So if we look at this where I have a variable, a string, or not a string, but in this case, if it's a true false, we typically refer to it as a Boolean. So when it says Universe Eaton, var Universe Eaton equals false. So that means it's a Boolean value, because if we say something is false, its only other possible value would be true. So then if we later change it to true, and then we log out the message, theoretically at this point we should see its most current value. I'm going to do one other thing here, just modify this. So I'm going to log it out twice. So look at where it starts out. It's going to log Universe Eaton once, then it will log it again. Now, with that in mind, mentally think ahead about what you think the log is going to be. Then when I look at it, we'll see that it first starts out and it gives me a true value, and then we reassign its value to false, and it gives me a false value. So things can, when they're a Boolean, they have a true or a false value associated with them. That's not, that, I mean, I think you're underwhelmed the fact that, this is even an example. You're like, okay, yeah, really, yeah, little snickers, eyebrow raised. But where it really matters is when we start doing comparisons, when we start asking questions about, is something equal to something? So effectively we're saying, if first number is equal to second number is true, then we're going to log out the numbers are the same. Else we're going to log out the message the numbers are different. So with this is now a conditional statement. So we say if, and then the condition that we're checking on, thus it's a conditional, and then we log out a message, else we log out the other message. So we're just now comparing these. Now, those of you who have done some programming before, whether it's in Flash or processing, you may notice that it's a little bit different here, that I have not one, not two, but 3 equal signs in a row. But there's a very special reason that we're doing this, and we'll get to that in just a moment. But if I open up this document and take a look at it, we'll see that the numbers are different. If I change this one to a 2 and then pull it up again, we'll see that now the numbers are the same. So we've proven that my conditional statement does indeed function. But the triple equal sign is a little bit different than a double equal sign. This is something that JavaScript allows us to do, where we can say, hey, is the first number the same as the second number? And are they the same kind of object? Are they the same thing? Because going back to the very beginning thing where we start looking at numbers and strings and wondering, it's like, well, okay. If we say, no, we don't want to do that one, comparing values here. So if we're comparing these numbers, or if we're comparing strings, are they the same? But under values here, first number and second number, they're both 12. But one is a number, one is a string. So they're not quite the same thing. So I would hope that it would be smart enough to tell me that. And it's telling me they're different. Because it's recognizing that. It says, well, they're both 12, but they're not the same kind of 12. One has a different 12-ness to it. But if I use two equal signs and not three, they're the same. So two equal signs goes back to, in other languages, when we've compared something, we always use two equal signs. We use a single equal sign to assign a value, a double equal sign to compare values. A triple equal sign says, hey, I'm comparing these values, but I also want to confirm that they're the same kind of thing. They're both numbers, they're both strings, they're both the same kind of object. Maybe they're both characters, or both the player, or both enemies, or both. But when we're comparing apples to apples, we don't care that this apple somehow is orange in color and totally rounded and doesn't have an indent or a stem and looks very much like an orange, but it's still an apple. We want to know, if we're comparing apples to apples, we actually want those apples to be apples. So the triple equal sign means that we are now not only requiring them to be the same thing, or to be the same value, but also to be the same kind of object. And in this case, they should both be a string or both be a number. So right now, with the triple equal sign, comes up and they're different. But if I put quotes on this one as well, so they're both quoted, now we'll see that the numbers are the same. They have the same value and they're the same kind of item. So triple equal sign is pretty much considered anytime you're doing a comparison value using equal signs in JavaScript, you always do a triple. That's, unless you have a reason not to, you should always do a triple, because otherwise you could run the risk of comparing and they should be the same, but they're not, based on how your program went. And when you have thousands of lines of code, it's really easy to screw things up. And if you don't use this strict equality, is what we refer to it as, you can run into issues. So the good practice is to always make sure you use the triple equal sign. Continuing forward, we'll see that in addition to equality, we can also then compare with greater than or less than. So we can use the greater than symbol. So if first number is greater than the second number, and in this case it's not, so I would say the second number is greater if we log this out. The second number is greater, so it's doing what we would expect. So it's behaving nicely, so that's good. Now, as we compare strings, strings are like numbers. Ideally, we should use strict equality once more, but we don't have to, but it would be recommended to do so. Just like in numbers, you don't have to, but it's recommended to do so. If you don't use the strict equality, a few of the style police will come knocking on your door. and say, oh, bad you should have done this, that's a bad practice. Most people who are actually doing stuff will be like, did your code work? And you'll say yes, and they say, okay. But next time you might want to think about this. And then your code breaks because you did it, and then you realize there's a fundamental flaw in your code. But in general, though, I mean, if you don't use strict equality, it's not the end of the world. But it's when we start looking at what is or is not a best practice or a good practice to follow stricter equality is recommended one of those. People should do it. If you go pull JavaScript up from probably 8-10 years ago, nobody did because it was much more fast and loose the way people worked with it. But as it's grown in its ubiquity and popularity in recent years, we're starting to see people actually care about and try and figure out what are some of the better practices, and strict equality is one of those. Compound if-else-if statement, so if, else, if, else, if, else. It's always a good idea when you're doing else-if statement to always end with an else, or to have a default statement at the end that is well, if none of the others were true, then we'll end with this one. So it's a good practice to always have that final else, especially when you're doing error checking in your project. So if you're try this and catch your error and show this, and it's a good idea to always have your kind of final statement be, so if nothing else worked, it sends you a message. So then when you run your code, so that if var was cat with 2 T's, and now if I run this, let's see, I don't know what it is. And for that matter, that looks really close to being correct. But if I run this, we'll see that it's not a cat still. Don't know what it is. So sometimes something as innocent as an extra space will trip up your code. If it's in quotation marks, a space is as important as a letter or number character. Anything in quotes counts. So even though you don't readily notice it, if I look here very quickly, I wouldn't notice the space after the T in cat. So I'd be like, why is it not working? That's why it's good to have that default statement. Because if you don't have that final else here, now if I run this, talk about failing silently. You're like, okay, I just ran an if statement. I wanted something to happen and nothing. So when things like that occur, that becomes the, oh, yeah, perhaps I should try and cover all bases and all possibilities to make sure that it's sending me a message so I know what's going on. So then when nothing is happening, you realize, oh, okay, now let's try and figure out what it's like, okay, well, I said cat, it's not cat, and then you'll finally realize, oh, there's a space up there. Get rid of the space, and it works. All right. A switch statement is just simply a if, else, statement written a little bit differently. So it's the same kind of thing. If we look at this where we have if animal is horse, console log it's a horse. If animal is mouse, console blah, 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 else console, I don't know what it is. The switch statement looks like this. So we're switching on, the variable or the object that's fed into this animal, and then we're saying, well, okay, if that animal is a horse, log this out. If it's a mouse, log this out. If it's a cat, do this. And if we don't know the default case, if nothing else proved true prior to that point, then we put the I don't know what it is. So with this, it's doing the identical operation as the if, else, if thing, but you will notice there's a conspicuous lack of curly braces. We don't have all kinds of curly braces here, where when I look at the compound switch, you see curly, 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 curly. And if you've typed enough code, it's really easy to forget a closing curly brace, and then your world comes to a crashing halt, and it's very sad, and there's much of gnashing of teeth and pulling of hair. And so when I look at the switch statement, I can see that, actually, this way I don't have to keep going between them. So with the switch statement, I think it's a little bit cleaner that way. So we say, well, we're analyzing on the case when it's a horse, And then we send this out. Well, in the case when it's a mouse, do this. Case when it's cat, do this. And then the final case would be default. And then we do that. So I think this is a little bit cleaner, but the syntax is very critical. We say case, then we say the case that we're looking at, say what's going to happen, and then we have to put in this break. Now, if you don't put the breaks in, what will happen is the first time something is true, then it will just go all the way down until it finally hits a break. And so even if it was a horse, if there were no breaks until cat, then it would log out cat even though horse was true. Switch statements get really wonked if you don't put a break in. And putting the breaks in is super easy to forget. And then your thing doesn't work. So they're not this end-all be-all better than if-else-if statements. And sometimes an if-else-if is easier to write. But if I had my choice of a complicated thing where I had half a dozen different things I was checking against and what I wanted to happen with each one, I use the switch statement because I find it's a lot easier to read than suffering through all those curly braces. So I find all the curly braces in the if-else-if to be a little bit more annoying to read. And now, right now, these braces aren't cuddled, but if we were to go with the cuddle method of braces, then we can see that the whole thing will get even a little bit more interesting to try and read through.
You don't like the cuddle method?
No, I prefer cuddle, but the source that I was pasting a bunch of crap in didn't cuddle. So I prefer cuddling. I always will cuddle my braces because it just makes me feel good inside to have cuddled braces. But you can decide whether to cuddle or not. And there are schools of thought when it comes to what is right and what is wrong in JavaScript. And we're going to continually go, well, this person says this one says this, and you get to decide which one you want to do, especially when they both work. There are some developers that maintain we should never cuddle, and other developers say we should always cuddle. So you can decide, are you a cuddler or not? It's up to you to come to that conclusion. So with our if statements, sometimes we need to use a compound if statement. So we have to want two items to be true or two items to be false or whatever the case may be. But we are now, with our if statement, we're saying if spell is broken and the witch is dead. So we're doing both. So both of those have to be true. So if the spell is broken, which it is, and if the witch is dead, which it is, it will log out game is over. But if either one of these were not true, but if one was instead false, so one is true, one is false, spell is broken, yep, that's true, and witch is dead, nope, that's not true, so then it would log out, keep playing. So the and sign says we want multiple things to have to be true, which is a little different than the or sign, which is not represented by two ampersands, but it's represented by two of the pipe character, or we refer to it as the double pipe. And the pipe character is right below the delete key. You hold down shift and then you hit the key right below delete on your keyboard, or backspace if you're on a Windows keyboard, and then it will allow you to do the pipe character. The double pipe signifies the word or. So don't type in the word or. So when we're working together and talking about writing conditional statements, and if I say if this condition and that condition, don't write the word and, put in two ampersands. If I say this condition or that condition, it's a double pipe. So in programmer language, we represent the word or by two vertical lines. We represent the word and using two ampersands. So that's just how the language has been made, so we just need to deal with it. So functions are where we're able to take a series of instructions and we're able to encapsulate them into a reusable entity. So we have done functions in processing before. You can do functions in Flash. In every language, a function gets defined. The way that you actually have to declare it and write it out a little bit different. So there's some nuance, some subtlety that factors into that. Right now, what we are using is referred to as a function declaration. And this is where we start moving into the, well, this book says we have to do things this way. This one says do it this way. This blog poster says this. This one says that. There are two very common ways of constructing functions inside JavaScript. One is a function declaration, where we start out with the word function, and then we list the name of the function, throw in a couple parentheses, and some curly braces to wrap the meat of the function. The other method is we will use a var statement. So we'll say var, and then we get to declare the function that way. So if we do that, it's a function expression versus a function declaration. Right now we'll use the function declarations. They both work. There's pros and cons to using each. But in the beginning, we'll just use declarations because it's easier. If we're using expressions, then we have some additional things to worry about, but having done so guarantees that potentially our code will be less fraught with trouble down the road. So again, more work on the front end means less debugging later. If you go fast and quick at the beginning, you may have some more issues debugging later. So it's where do you want to spend your time and effort is what it really comes down to. So with this, I have a couple variables, and then I'm doing a function call. So I'm calling that function, and we do that by specifying the name of the function, and we throw a couple parentheses after it saying go. That's really what it is we're telling that function go, run, do whatever you're supposed to do. And then my function, defined by the word function, and then its name add, couple parentheses, curly braces, and then inside that it creates a variable, calls it total, adds in a couple numbers together, and then it logs that out to the console. So you may be thinking, it's like, well, why do we need the function here? Because this is exactly the same code that we did prior. But remember that when we're using a function, what we're trying to do is we're trying to take the logic, some set of instructions, encapsulate it, so then we could potentially call it from a variety of places. We could call those coupled lines of code. And in doing so, that means I don't have to rewrite these lines of code over and over and over as I would need through my project. So the more you can organize your programming so that you have functions, each function does one kind of primary task or activity, and that task or activity may be to call a bunch of other functions, and then those functions call other functions. So you can have this nesting ability, but that makes your code much more portable, much more modular, and then you can take pieces of it and recycle it much easier from project to project versus having to start over every single time. So got my variables, calls the add function. When add is called, it now creates this new one and then logs it out. So now if we run this, oh, wrong key command. Let's try again. Let's see that. Okay, it logs out a 7. So it did exactly what it should do. So I'm just going to add a little text to it because it's going to work with this a little bit more and modify it so we can see some stuff. So the total is 7, so it's working. Now, right here, if I were to say something like console log total. So oh, JavaScript got grumpy with me. It did the first line, because remember the computer always executes in the order the lines are. It starts at line 1 and then 2, 3, 4, 5, blah, 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 blah. So it executed, kept going on down, line 10, line 11, line 13. Okay, that worked. 13 called this function. And then console log total. Well, I asked it to log out total, but the problem it's running into is while total is defined as part of my add function, total only exists inside my add function. So it doesn't actually have access to it. It can't do anything else with it. The only person who has any knowledge of my variable total is my add function. So anyone else who would try to access it does not, because total has a scope. It's only available inside that function. So when we have variables like first number and second number, they're available to anything in my script because they're not inside curly braces. This is going to be really important that you will start writing functions and creating objects, and then there will be methods or functions and properties and other things inside those. And the scope of those, who has access to your variables, is going to become really, really important. So this is the scope of the variables is something that is going to become, we will revisit this time and time again throughout the semester, because you will create things and then realize that variable is not in the scope you need it to be in. But it also is something that we have to keep in mind, that if you build a web page and now you link to, say, some other scripts, maybe to an analytics script or to a advertiser script so it throws ads on your web page, and then you link it to a library like jQuery, and then you have your own custom scripts that you've put in. If you're not careful with the variables that your script is accessing, you run the risk of unintentionally accessing the variables on some of the other scripts that your page is linking to, and that could cause no end of headache. Because if you both have something with the same name, which one do we use? It's having identical twins with this identical name. Which one did we actually mean? I don't know. Well, the one on the left. Well, how do I know that one was on the left? They just switched places. Well, now, yeah, I give up. So the scope of the variables matters. It's really important to keep in mind that they exist inside curly braces. So if they're wrapped in curly braces, so they are defined in a curly brace, that means they live inside the curly brace and they die outside the curly brace. That's their little protective shell. So when you're defining your variables, you need to be careful with it. There's one programming technique where you take your entire kind of main script that's powering your web page, and you actually wrap it inside a function so that it's inside a set of curly braces. So all the variables, all of the data, everything that's part of your project are now self-contained. So any other scripts that are linked to on that page will not be able to access, won't even know of, or have any dealings with the script or with the variables of your document. So that can actually be a very fundamental technique, and we'll have to look at that as we move into some more complex projects. Functions that have parameters associated with them, so we pass a value to that function. So if I'm calling this function and I'm passing the string to it, and then it is now looking to receive something, and then it will log that thing out. It's a very common practice. It's more common to write functions that accept parameters than it is just to write functions that don't accept parameters, because more often than not, if you're writing a function, you want it to know something, so you're sending something to it so it can do something with that piece of data, whether it's a number, whether it's an object, whether it's a file, whether it's a string. So this now, when I call that function with and pass this string to it, we will now see logged out hello. But if I passed a number to it, logs out the number. So it's just simply spitting out whatever I sent to it. Now, you could say I could just write a line. I don't need a function or anything. I could just say console log 7, and then that would have worked. And yes, I could. But once we start using functions, that means we can have multiple things accessing that same function. That's the real power of a function, is I could have a mouse click and a keyboard press both call and activate the same function. So if I put a form field and expect the user to type something in, then I have a submit button. Well, most of us have grown accustomed, if you're typing on a web form, that you hit the enter key. That's the same as hitting submit. So it should be then, when I hit the submit key, or enter key, it calls my submit function. When I press the mouse button on that button, it calls my submit function. So both should be able to access that same set of instructions. And that's one of the, that's just a real easy scenario of why we would use a function. We can pass in multiple values into a function, so I can pass in two numbers, add it together. Can look at that. It looks a whole lot more impressive when we turn it into a full calculator where we have functions for add, subtract, multiply, and divide. So we can see now it logs those out. So this is similar to what we had before where we just logged out these adding and subtracting values. But if we view that we're now passing in information to it, then it makes it a whole lot, each one is a lot more powerful. It's very common, especially in a lot of visual programming, to build your own set of utility helper math functions that you can then call that may perform something, so you don't have to write out 6 lines of math for computing something. You just send the value to it. It gives you the kind of thing you want, so you don't have to memorize your formulas and memorize a bunch of things. You can just say, hey, I need to know the distance between these two objects. Well, that's not natively built into the language, but we can easily create a math function that determines the distance between 2 points on screen. So then I can just pass the coordinates of those 2 points and it will spit back a distance value, and the angle between the two, or whatever kind of math I wanted to determine, and we can figure that out. Now, this example with return value gets a little bit more complex. This is where it gets a little bit more interesting. So when I have a return value, what's going on here is I can have a function that now it accepts a couple values into it. It has 2 parameters, first number and second number, and then it will do the appropriate math operation to it, and then it returns that local variable, that variable inside the curly braces. And then we're setting a variable equal to that function call. So addition is really equal to that value. So when we call add, it returns back this number. So when I call add, it accepts 12 and 6, it adds those together, it returns the total of those, which would be 18. So now my variable addition is equal to 18. On real basic math like this, it almost seems like, why? But again, back to the examples of visual and game programming where you typically are trying to figure out distances and angles and rotations and vectors and other sorts of things to move and manipulate objects on screen. Having these helper math functions can be a great asset where you just pass in a few values that throw something back at you and you're up and running. And a lot of agencies end up building their own custom math library that they're able to just link their projects to, so then all their developers have access to the standard math equations that they use on all of their projects. And it's a really useful way of doing things, so you don't have to then recode or kind of reinvent the wheel every single time. Because if you realize you're doing the same thing over and over, it makes sense to come up with a standard way or a reusable set of assets that you can take from project to project. This is part of why you hear the word framework thrown out in the kind of design and development community, where we use these frameworks. People realize they're doing the same thing repetitively. If you get a framework that does a lot of the scaffolding, the heavy lifting for you, and then you just populate it with your details, with your content, and tweak it for your custom application, it's a whole lot faster than starting from scratch every single time. Oh, funny. These are out of order. Oh well. Now, function expression, just going to mention it. We're not going to deal with them too much, but it's worth seeing because if you happen to read any books, if you go online and look up references, you may run across a function expression versus a function declaration. They're both fun because they start with the word fun, but they're fun in different ways. Now, if we look at this particular example with add, and if we compare that to the previous function of add, we'll see that there's a couple different, I'm just going to get rid of the differences I added so they're both in their original pristine form. So if I have this add here, don't want that one. And there's functions and function expression. So if we look at this function expression, if we look at the function declaration, we'll see that there's a couple differences, a couple nuance subtleties between them. We'll see that the function declaration here, we're able to access the function anywhere. If we look at the function expression, you'll notice that the function has now been defined first. This is one of the supercritical differences between a function expression and a function declaration. In a function expression, you do not have access to that function until it's been defined. Remembering that the computer likes to execute code in a numerical line order sequence. So line 2 after line 1, line 3 after line 2, line 4. So it goes in order. But if I look at my function declaration, line number 13 is calling for information from line 15. So line 15 theoretically hasn't even happened yet, but it's now asking for it. So that's causing a little bit of, at times can cause difficulty, because if I was trying to add something, but I didn't have in place what I needed, like say an image or sound file that needed to be loaded into memory, and then I say, hey, let's go do something with this, but I don't have it yet. A function declaration would be like, oh well, we'll make do. We can in the technical term it's called hoisting. So it can grab functions from the end of your script and pull it up to the top and have access to them. But a function expression is not allowed to do that. So that if I run this document right here, we'll look at it. We'll see, okay, it spits out 8. If I do something as simple as put my add here and now function, so it looks very much like this one. We add and then we run it. So they're very similar. But now if I do it this way, oh, evil cryptic error message. Even more cryptic than any of the others we've looked at so far. Could we use the word object any more times? Probably not. So we're like, oh crap, really? I was doing so well, and no red for like 10 minutes. This is a good day, and I'm bummed now. But the reason it failed is line number 9 is asking for the add function, but the add function doesn't even exist in memory until line 11, so it failed. So the moral of the story is, when you use function expressions, do them all at the top of your document. Now you may also notice the function expression starts with the word var. That's also why we typically recommend you always do all of your variable definitions. So you define all of your variables at the top of your document, because you will always get error messages if you try and access something before it's in memory. So if it's a variable and you're trying to access it, it needs to be in memory. When that function is a variable, it needs to be in memory. So once the function expression has been used, there is no, once it reads it, there is no difference between an expression or declaration function. They both will now perform equally well. And the reason that you may wish to use a function expression versus a function declaration is by intentionally having to define your functions as function expressions at the beginning of your document guarantees you will not try to access something before it's now available. If you use a function declaration and all your functions end up at the bottom of your document, but you're calling them, but things haven't been loaded properly yet, then you're going to start getting undefined errors where it starts saying, oh, undefined object, blah, blah, blah. And you're like, well, and then you realize, well, 6 functions later is when it was loaded, but, so you're calling things out of sequence. So some schools of thought say you should always use function expressions to prevent you from accessing things before they're available, because all your variables get defined at the beginning of your document, whether they're a function variable or a normal variable. And other developers will say, "Puh, I don't care. I'm going to just use function declarations because they're easier to write." Both are right. And you can decide what works for you. When you go look up sources, though, and this is why I bring this up on day one, when you start looking up online and start looking at code, because I'm expecting that you aren't going to rely on, I'm not going to just feed you code and then you figure it, do it all from that. I'm expecting that you're going to be working in that very nefarious scary place called the internet, where there's all kinds of code running around in the wild. And you're going to be finding things and working with it. And sometimes they will use variable or function expressions, and sometimes they'll use function declarations. And you'll be like, wait, they both say function in them, but one's a variable, one's not. So we need to know this right up front in the beginning. Because when I first started migrating into JavaScript, this threw me for a loop, because I'm like, well, but they can't be the same thing. They are the same thing. It's just when you're defining them, and then there's certain kind of drawbacks and limitations. The variable function expression is a little lengthier to write. It doesn't look quite as clean, but it guarantees that if you do it at the beginning, you will not be accessing it before it's time. Function declarations they feel just like, well, that's how I do it in all my other programming languages, so that must be the right way, and that's how I should be doing it, and we go with it that way. Now, all of the routing of things to the console is great, but it's a whole lot more fun if we can actually modify the markup on the page. So if we can actually access the HTML, that's way cooler, I think. And that's what this next document does. So in this document, what we're actually able to do is we're able to gain access to one of the elements on the page. We're able to change the contents of that, its inner HTML property, and fill it. Now you will notice that that element actually has no content in the beginning, and then we're going to populate it with hello world. So if I look at this and pull it up on screen, we can say, oh look, it says hello world. And I'll verify, look, there's no evil cryptic error messages in bright red, there's nothing else going on, it's just there. It says hello world. So what's happening here is we create a variable object, and it's very common, it's a very common practice that when we're trying to access a variable object in our markup, or when we're trying to access an element in our markup, we create a variable with the same name as the identifying information for that markup element. So in this case, I'm trying to access a paragraph with the ID of output. So I create a variable and call it output because output matches that. So this variable here does not have to be the same name, but it's very common. So for the longest, I avoided doing things like that, and because I thought, well, no, I need them separate so I can see that, well, this is output thing, that's output, because I didn't want it to be the same, because then I would be confused as to which one I'm referring to, and eventually I realized I was more confused by trying to come up with multiple names than I was just going, okay, if it's called this in my markup, I'll refer to it by that name in my code, and then that way I know exactly what I'm talking about. Now we're using a method called query selector. Query selector is nice because it allows you to access both IDs and classes. From a performance standpoint or in a production mode, so if we're actually kind of turning this loose on a real project where we need good performance, query selector probably should not be used because it is a slow method. So if we were query selecting and accessing hundreds or dozens of elements on our page, we potentially could see a little hang up while the page is trying to figure out what's going on. There's other methods that are considered better practices, but for right now we're going to use this because query selector can access both classes and IDs. because otherwise we have an easy way to get ID, we have an okay way to get tags, and we have a crappy way to get a hold of classes. So right now in the first early part of our learning, we're just going to use this because it works. So we say document, and then we call the query selector method. So this is something that is hard baked into the document, that it now knows how to do this. And we say, hey, grab that ID called output, and then we're going to change the inner HTML or the contents of that to hello world. And that's simply all it takes to both access something, put it in a memory, and then modify its contents. That's all we have to do, which I think is really fun.